Why is the sky blue? A clear cloudless daytime sky is blue because molecules in the air scatter blue light from the sun more than they scatter red light. When we look towards the sun at sunset, we see red and orange colors because the blue light has been scattered out and away from the line of sight. The white light from the sun is a mixture of all colors of the rainbow. This was demonstrated by Isaac Newton, who used a prism to separate the different colors and so form a spectrum. The colors of light are distinguished by their different wavelengths. The visible part of the spectrum ranges from red light with a wavelength of about 720 nanometers, to violet with a wavelength of about 380 nanometers, with orange, yellow, green, blue and indigo between. The three different types of color receptors in the retina of the human eye respond most strongly to red, green and blue wavelengths, giving us our color vision. Tyndall Effect. The first steps towards correctly explaining the color of the sky were taken by John Tyndall in 1859. He discovered that when light passes through a clear fluid holding small particles in suspension, the shorter blue wavelengths are scattered more strongly than the red. This can be demonstrated by shining a beam of white light through a tank of water with a little milk or soap mixed in. From the side, the beam can be seen by the blue light it scatters, but the light seen directly from the end is reddened after it has passed through the tank. The scattered light can also be shown to be polarized using a filter of polarized light, just as the sky appears a deeper blue through Polaroid sunglasses. This is most correctly called the Tyndall Effect, but it is more commonly known to physicists as Rayleigh scattering, after Lord Rayleigh, who studied it in more detail a few years later. He showed that the amount of light scattered is inversely proportional to the fourth power of wavelength for sufficiently small particles. It follows that blue light is scattered more than red light by a factor of 704 = 10. Dust or molecules? Tyndall and Rayleigh thought that the blue color of the sky must be due to small particles of dust and droplets of water vapor in the atmosphere. Even today, people sometimes incorrectly say that this is the case. Later scientists realized that if this were true, there would be more variation of sky color with humidity or haze conditions than was actually observed, so they supposed correctly that the molecules of oxygen and nitrogen in the air are sufficient to account for the scattering. The case was finally settled by Einstein in 1911, who calculated the detailed formula for the scattering of light from molecules, and this was found to be in agreement with experiment. He was even able to use the calculation as a further verification of Avogadro's number when compared with observation. The molecules are able to scatter light because the electromagnetic field of the light waves induces electric dipole moments in the molecules. Why not violet? If shorter wavelengths are scattered most strongly, then there is a puzzle as to why the sky does not appear violet, the color with the shortest visible wavelength. The spectrum of light emission from the sun is not constant at all wavelengths, and additionally is absorbed by the high atmosphere, so there is less violet in the light. Our eyes are also less sensitive to violet. That's part of the answer, yet a rainbow shows that there remains a significant amount of visible light-colored indigo and violet beyond the blue. The rest of the answer to this puzzle lies in the way our vision works. We have three types of color receptors, or cones, in our retina. They are called red, blue and green because they respond most strongly to light at those wavelengths. As they are stimulated in different proportions, our visual system constructs the colors we see. Thanks for watching. You'll love this. Like and share now. And subscribe now.